Alrighty, calculus. Welcome to the continuation of the lecture that we couldn't finish in class. This is going to be limits at infinity. I'm just going to basically work in MS Paint and do some examples and refresh your memory on different things. I want to quickly start off with the numbers 0, any number, and infinity, and refresh your memory on the ratios and what they equal. I seem to have lost my cursor. Here it is. So let me get a nice little brush here. Let me get some nice black. Let me get some nice red. Okay. We've got the numbers 0, n is going to represent any number, and then infinity is infinity. And I want to go quickly through these 6 possible ratios. 0 divided by any number, I hope you know, is 0. 0 divided by infinity is equal to 0. And 0 over 0 is, it's undefined, which means not that you're done with the problem, but you need to try some trick that we've learned. Okay, next possibility. A number divided by 0. Well, if you have a number divided by 0, that's probably going to be plus or minus infinity. When you take the limit and, this is very crude, but in general it's going to end up, the problem will end up equaling plus or minus infinity. If you have a number over a number, you're going to get a number. And if you have a number over infinity, you're going to get 0. So it doesn't matter how big the number is, even if it's 100 billion billion billion, if you divide it by infinity, it's going to equal 0. Okay, third column, infinity over 0, that's definitely going to be very, very big. It could be plus or minus infinity. If you have infinity over a number, that's definitely still very, very big, plus or minus infinity. And if you have infinity over infinity, now, again, this is a problem because, okay, these two infinities might be the same size, one might be bigger. Again, you have to try a trick. So I know this was super quick and fast, but you should already have known all 9 of these possibilities. So 0 over 0, you don't know how small or how big those zeros are. Infinity over infinity, you don't know how small or how big those zeros are, so you have to try a trick. In these 3 cases, the denominator is always bigger than the numerator because the numerator is 0, or because the denominator is infinity. So in these cases, the denominator is infinitely bigger than the numerator, and so the answer is 0. In this case, they balance out, so you get some number. Note that the number you get doesn't have to be the same as these numbers. I'm just using n to represent any number. And finally, in these 3 cases, the top is infinitely bigger than the bottom, and so therefore the answer will be a positive or negative infinity, depending on whether the infinity itself was positive or negative, and whether the 0 or the number was positive or negative, different combinations. Notice there's 3 possibilities that equal infinity. There's 3 possibilities that equal 0, and then there's one that's a special easy case, just a number, and there's 2 that require special tricks. Try a trick, try a trick. So, in this section of the textbook, we're taking limits where x goes to infinity, so we're typically going to have something with an infinity in it. So something like this, or something like one of these. Okay, so if the denominator has the infinity, and the numerator has a number, or, sorry, let me start over. If the denominator has an infinity, and the numerator is 0, or a number, either one, doesn't matter what's in the numerator. If the denominator has infinity in it, the answer is always going to be 0. So these 2 are super easy. Let me get another color here. Okay, these 2 are possibilities in which the answer will be 0. Okay, these 2 are possibilities in which the top is bigger than the bottom. Okay, if the top is bigger than the bottom, then the answer is going to be positive or negative infinity. And the last possibility is the top and the bottom are both infinity, and now you have to see, okay, are they the same size of infinity, or is one bigger or is one smaller? So if the top infinity is bigger, you're in a situation like this. And if the bottom infinity is bigger, you're in a situation like this. And if both happen to be the exact same size of infinity, we can kind of cancel them out, so to speak, and take the ratio of the coefficients. Okay, so now I'm just going to show some practice problems. I'm just going to make some up as we go. All these are going to be limit as x goes to infinity. So I'll write it the first time, and then I'll stop writing it after that to save time. Limit as x goes to infinity of some big function. Let's do x to the 4th minus 3x over 2x squared plus 7. Okay? So the numerator has x to the 4th. The denominator has x squared. So both the numerator and the denominator are going to infinity. So at first glance, this looks like an infinity over an infinity. Okay? Which means you have to try a trick. So the trick is this idea that the top is getting infinitely bigger to the 4th power, and the bottom is only getting infinitely bigger to the 2nd power, and so the top is still infinitely bigger than the bottom, and so your answer is positive infinity. Positive because this is positive infinity, and this is positive infinity, and a positive divided by a positive is still a positive. Final answer, positive infinity. Okay, next example, still the limit. Let's try something fun. X to the 71st plus 1. X to the 72nd plus 1. Okay, when you have infinity, let's write it in. When you have infinity to the 71st power, adding 1 doesn't make an ounce of difference, right? So those don't really matter at all. And you just look at these and we say which one is bigger. X to the 72nd is bigger than x to the 71st, and therefore the bottom is bigger than the top. And so it's kind of like a number divided by infinity. The bottom is infinitely bigger than the bottom. Sorry, the bottom is infinitely bigger than the top. And so your final answer is going to be a big fat 0. And it doesn't matter whether it's positive or negative because positive 0 and negative 0 are both the same thing. Okay, but you can also have a little more fun or tricky problems. So let me make a little space right here. You can have cool things like the square root of x squared plus 2x over 6x minus 4. Okay, what do you do in this case? Oh my god. Well, this requires you to be a little clever. First, start under the radical. Okay, you've got x squared and you've got 2x. When you take x in the limit that x goes to infinity, the x squared is so much bigger than the 2x that the 2x pretty much doesn't matter. In fact, it doesn't matter at all. This is infinitely bigger than this. So if you have something that's infinitely bigger than something else, then you can completely ignore this guy. This is totally meaningless compared to the thing we're adding it to. Okay? And how about this negative 4? It's totally meaningless compared to 6 infinity. So we can cancel that out. Now we've got this square root of x squared. Well, the square root of x squared is just x over 6x, and now we can say, both of these are the same size. They're both x to the 1st power. So those guys, they both go up to infinity, but they go up at the same rate. And the rate that they go up at is the bottom is always 6 times bigger than the top. So the final answer is just 1/6. The ratio is always going to be 1/6. And if this doesn't seem intuitive to you, try plugging in numbers. So first try plugging in like 10, x equals 10, and see what you get. And then x equals 100, and then x equals 1,000, and then x equals 1,000,000. And you'll see that the bigger value you make x, the closer and closer and closer this overall result comes to equaling 1/6. Okay, so when you're simplifying these kind of problems, first look and see, can you see right away if the top is bigger or if the bottom is bigger? And by bigger, I mean x to a higher power. If that's the case, your answer is right away either infinity or negative infinity when the top is bigger, 0 if the bottom is bigger, and if they happen to be the exact same size, then you have to do a little bit of work to find the ratio of the two. And the ratio is, by ratio I mean whatever number is in front of here and whatever number is in front of here. So in this case it was a 1x and here it's a 6x. So the ratio of these two coefficients gives you the answer that you want out. And the last thing I'll say before I cut you loose on the homework is you can always check these guys in your calculator. First plug in 100, then 1,000, then 1,000,000. And if you look at those three numbers in sequence, you should be able to easily see a trend. Either they should be stabilizing, they should be going to 0, or they should be going to positive or negative infinity, which means they're just getting bigger and bigger without bound. Okay, I hope this video helped, and email me if you have questions, and we'll go over it in class next week.